Okay, so we're going to solve problem 3.95 now. So the book gives you an equation, which is basically, let's write that down here. That's what you always should do when you solve these problems. Write down the equation. So I'm just copying the equation from the book. Okay, so there's the equation. Now, what the book gives you is the grams of starting materials that you have out here. Okay, so I'm going to write down the grams that is given to you, and make this a habit from now on. Always write the amounts given to you. Okay, so I'm just gonna write a small thing here saying given, so you know what's given to you. So 4.15 grams titanium dioxide is given to you, 5.67 grams carbon is given to you, 6.78 grams chlorine. And now what they're saying is this reaction goes to completion. So they're saying that assume the reaction goes to completion. That means whatever you have out here completely reacts to form the products. Okay. However, what they haven't mentioned to you and what is very subtle out here is that only one of these reagents is the limiting reagent. Okay, that means some of these reactants would be left over. Now your job is to figure out which one is completely consumed, because that's the one that's going to dictate how much titanium tetrachloride is formed. So in order to do that, what you want to do is you want to relate each one of these reactants with the amount of product formed. Okay, so let's see how you do that. So the first job that you have is to calculate the molar mass of each reactant, because that's going to be very important. Okay, so I pre-calculated the molar masses just for convenience. If you do the calculation, you should come up to the same numbers. So the molar mass of titanium dioxide is 79.8658 grams. Molar mass of carbon is 12.0107 grams. Molar mass of chlorine, I'm going to draw an arrow out here so it makes it more, so you know what you're talking about. Molar mass of chlorine is 70.906 grams. And finally, since we're interested in the titanium tetrachloride, I calculated the molar mass for that, which comes out to be 189.679 grams. Okay, so this is something which you can calculate very easily from the periodic table. Okay, so now once we calculate it, now we got to figure out which one is the limiting reactant. So now you're going to figure out the limiting reactant. So for convenience, we're going to abbreviate this as LR. Okay. So how do you do this? Very simple. You start off with the grams of titanium dioxide that you have. So we're going to choose titanium dioxide. We're going to figure out if this guy is limiting or not first. Okay. So we're going to take this and we're going to relate him with titanium tetrachloride. Okay. So grams of titanium dioxide. So write out the grams given to you. Okay, and then you want to find out how many moles of titanium dioxide are there in these grams. So you want to multiply it by the correct unit factor. So we're going to write 1 mole titanium dioxide divided by the molar mass, which we calculated previously, 8658 grams. Don't forget to write titanium dioxide out here. So once you write that, now this entire thing should give you the moles of titanium dioxide. As you can clearly see, grams and grams would cancel out, leaving behind moles. Now you got to relate the number of moles of titanium dioxide in your reactant that actually gives you the number of moles of product. So you're looking at 3:3. So this is very important, the molar ratio. Okay, and sometimes equations are not balanced, so you need to balance them. Luckily for you, this time the equation is balanced. Okay, so what you do is you multiply this and relate the moles in the next step. So now you have the moles of titanium dioxide, that is this quantity out here, what I'm going to do is I'm just going to mark that out with a different colored pen. This is the moles of titanium dioxide, okay? And you want to relate that to the moles of titanium tetrachloride, so you need to include another unit factor. So we're going to write 3 moles titanium tetrachloride on top, and you divide that by 3 moles titanium oxide on top, at the bottom. So once you do that, this entire setup out here should clearly help you calculate that 4.15 grams. It should basically help you predict how many moles of titanium tetrachloride you're going to end up with if you start off with 4.15 grams of titanium oxide, because you took everything into consideration. So I'm going to use a different colored pen. I'm just going to cancel out the common terms. So grams and titanium dioxide, grams, titanium dioxide cancels out. Moles, moles and titanium dioxide again cancels out. And if you see, once you cancel out all the units, you're only left with moles titanium tetrachloride. So we're going to write that on the right side, moles titanium tetrachloride. And now we're going to just do our math out here and crunch those numbers. So if you do the math correct, let's see. Okay, so we're going to take 4.15 times 3, divide that by 79.8658, which is equal to something, divide that by 3, which should give you 0.0. Let's express our answer with, you see, that's a whole number, so you don't take that into consideration for significant figures. So you're going to express your answer with 3 significant figures. That should be 0.05. It says 0.05196, but 6. So if you have to round to 3 significant figures, then 9 should become 10. So it's basically 0.0520. So that's 3 significant figures, okay? So that's how you figured it out for titanium tetrachloride. So that many moles of titanium tetrachloride should be formed if you start off with 4.15 grams of titanium dioxide. So we're going to do the exact same thing for carbon, okay? So we start off with 5.67 grams of carbon. That's how much is given to you. And now you're going to figure out how many moles of carbon that is equal to. So we put 1 mole carbon, divide that by the molar mass of carbon, 12.0107. Sorry, 12.0107 grams carbon. Multiply that, because now once you figure out the number of moles of carbon, you want to relate that to the number of moles of titanium tetrachloride formed. So you multiply that by the correct unit factor, so that should be 3 moles titanium tetrachloride. Divide that by 4 moles carbon, which should give you the number of moles of titanium tetrachloride formed. So just like before, what we're going to do is we're going to cancel out all the common terms, grams carbon, moles carbon, which just leaves us with moles titanium tetrachloride. So let's crunch some numbers once again. 5.67 times 3 divided by 0107 divided by 4, which should give you 0.354 moles titanium tetrachloride. As you can see, right now it probably is becoming evident to you that based on the number of grams given to you, you're already seeing that these reactants are actually dictating the number of moles of titanium tetrachloride formed. And what you're looking for is the one which gives you the least number of moles. So we already have a winner out here. It seems that titanium dioxide is giving you a lesser number of moles of titanium tetrachloride. But we have to consider chlorine as well. So we have to look at chlorine before we can make a decision about which one is the limiting reactant. So we're going to go for chlorine, just like we did for the others. So 6.78 grams chlorine times 1 mole chlorine. I need to sip my coffee. Excuse me. And the molar mass of chlorine is 70.906 grams chlorine. Don't forget to write that. Times. Now we're going to relate 6 moles chlorine to 3 moles titanium tetrachloride. So we're going to put 3 moles titanium tetrachloride on top divided by 6 moles chlorine. And now let's see. I'm going to cancel out everything which we can cancel out. There we go. Grams and moles cancelled out. All the chlorine is gone. Now let's crunch those numbers. 6.78 grams times 3. Divide that by 70.906. And you divide that by 6. Which should give you 0.0478 moles. Notice carefully. Again, I'm restricting myself to 3 significant figures out here. Titanium tetrachloride. So now, if you look at these 3 numbers, 1, 2, and 3, which one do you think is the least number of moles? And pretty obviously, this guy is our winner, right? That means, this tells us that chlorine is the limiting reactant, okay? So now once we figured out which one is the limiting reactant, what we really are trying to say is that this one is going to limit the number of moles of titanium tetrachloride formed. So you're never going to have more than this number of moles of titanium tetrachloride formed in this reaction. So what I'm going to do is I'm going to switch pages right now, because you need to calculate how many grams of titanium tetrachloride is formed. Let me see if I'm correct. How many grams of titanium tetrachloride can be produced? So to calculate grams of titanium tetrachloride, what you got to do is you got to take the moles of titanium tetrachloride and you got to multiply that by the molar mass of titanium tetrachloride. So the moles would be the limiting moles as we did on this sheet, so that should be 0.0478 moles. 478 moles. And the molar mass of titanium tetrachloride happens to be, we calculated that previously, that's 189.679 grams per mole. So we're gonna take 189.679, see if I'm right, okay, grams, put grams on top, divide that by moles, because that's the unit factor you want to use. Cancel moles, which leaves us with grams. So if you do the math out here, that should be give you 9.0685, and it keeps going, grams titanium chloride. But what you want to do is you want to limit your answer to 3 significant figures. So you can clearly see out here 1, 2, 3, that's greater than 5, so your answer should be 9.07 grams of titanium tetrachloride. And that's the answer.